Hey everyone, welcome back to my channel EduVibe. Today we will completing the unit Matter and Ionic Bonding with doing some extra practice questions of this unit. So this unit is have not have like any very tricky type of extra questions. Like we have a straightforward questions more in this. Like when we do a theory part at last and topics of this lesson of this unit, so that from there we get some tricky questions sometimes, but not like from the other topics when we do the other types of things. So we will do that and I'll tell you how the questions are coming in the examination and or the final exam. So firstly, we were doing the first lesson when we do with the atomic structure, and that a important topic from there is that energy level diagrams we have to make. So energy diagrams we have to make for these three of the atoms or the ions. We have first one is a boron atom. So boron is like denoted by B, and we have to find the what are how many protons they have. They have the five protons. So this have the five protons. So five protons, and we have a distribution. So first energy level we have two only. Then we have ability to hold up to one in the second one, but we have only three left, so we put only three. So in the valence electron, if we want, so in valence electron they have only three electrons. So that's how the boron atom work. Aluminium ion. Aluminium ion has about 13 protons in it. Atomic number of 13, so these are 13. So if you not know, so open your periodic table and you can see the atomic numbers on that. So aluminium denoted by Al. So first one has 2, second one has 8, and we left with only 3. So we put 3 electrons. So in the valence electron, we have 3 electrons. Sometimes, if we want to do other thing, like from the next lesson, if we do other thing, so you can see if we want, so this 3 in this or in this, if we lose that 3, not in that case, not like in boron case, but in that aluminum case, like we have the 8 electrons in the shell, and if we want to lose that electrons, so if they lose that electrons, so they get the negative charge on it, and the valence electrons have now 8 of them if we do the advance of that thing. But not in boron case, but if we get those 3 electrons, we left only 2 electrons. So we are basically doing with the 8 electrons, not with the 2 or the other valence electrons. So that's the thing also you can do. So last one we have oxygen atom. Oxygen atom has 8 protons, which is atomic number. So oxygen denoted by O, we have 2 of them. Then we have 6 electrons. So in the valence shell or valence electron, we have 6 electrons. So that's how the energy level diagrams can be made. So next one we have to do some chemical naming of the following ones. So first we have AgI. So how can we do that naming? So AgI, so this means that Ag is the silver. So they don't have any of the like moles, like one or two. They like basically have something. And I is called the iodine. I is called the iodine in your periodic table. But in that case, we have to like drop that INE and we will like convert it into by ide. So which is iodide. So silver iodide is that. And the more important thing that your first of the alphabets of the every naming should be small. Next one we have the PbNO2 and the 2. So PbNO2 and the 2 is like if we do some like that Pb, right? Pb has the of 2 positive they have, and NO2 is only 1 negative. So when we do that conversion, we get this. So as you see on your periodic table, you can see that Pb has the 2 charges, 2 positive and the 3 positive. But that 2 positive is over there. So 2 positive means that we have to mention that in the Roman ones. So we have lead, we have 2 like this, and we have this. It is a nitride, but we have to ignore that nitride. We have to find that nitride. Nitrate this have, so this is nitrate. This is a polyatomic atom, so the nitrate is fine. Next one we have the MnF4. So MnF4 we have. So those do not know that Mn is not very like, mostly we are using the other like not we using the Mn the most like frequently, but Mn is like the manganese, so which is so this is manganese, and that fluorine has a -1 charge. So fluorine if have -1 charge, so this manganese have -4 of +4 of charge. So then this will as a converted type, and we get Mn4. So this means manganese also has the uh, two of the charges. So this means we have to write that 4 like this, and then we have to write fluorine. We have to like ignore that INE, and we get fluoride. So it's FluORIED. So it's manganese for fluoride. Last we have SnO2. So at SnO2, so we know that Sn is the 10. So it's the 10, and what is that O2? O2 is the outside. So basically what we have to see over there, that Sn has the charge of something. So Sn has a charge of 4. If we count this has a charge of 4 positive, and O has a charge of 2 negative. When we cut this, we get 2 at this like. So if you see a periodic table, you have to often see that periodic table when we do the chemical naming. So that 2 is over there, but this is actually a 4. So 10 4 is this, and we have outside at last. So that's how the 10 4 outside made SnO2 from this side. So I have to know that how can we make that actual chemical formulas of this, which we practice now. So no, in the next round. Okay. So now we are making the electron dot diagrams. Diagrams are again very important topic of this unit, and very important when we do the ionic conversion in this, when we do transferring of electrons. So we have lithium, it has to be chlorine. So lithium and the chlorine. Lithium has -1 of charge. Like -1, Cl has on this positive one, this is -1. So when we made, we got LiCl. So LiCl, lithium has the, in the valence shell they have only 1 electron left. So we write only 1 electron. In Cl, as we all know that, this is the most familiar one. So it's 7 of it. 1, 2, 3, 4, 5, 6, and 7. If the lithium gives that gives the electron to this, so this will stable, and this will also stable. So what we get, so this will form Li, which is now negative Li, and Cl, which is now stable now, and get negative. So LiCl will made like this when electron dot diagram. Next one we have calcium redsphage phosphorus. So calcium has the charge of 2 positive, and the phosphorus has a charge of the -3. So we'll get Ca3P2. So this means we have a three of the calcium. So when we make the calcium, so outermost valence shell they have only 2. So you know that how we made this? We made like this in this. So from here you can see that what are the valence electrons we have in outermost cell. From here you can solve these type of questions when we do direct conversion, direct visual things. So we have a 3 of the calcium. If you want to make the 3 of calcium, you can make if you want. So I made the 3 of the calcium for more clarity. Or you can write just this. This is also right. So but for more clarity I do this. So plus we have a 2 of the phosphorus. Phosphorus has outermost shell of 5 of them. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now phosphorus want that all of them be stable with this. So what we can do, this one has transferred to this, and this one also transferred to this table. This one transferred to this one transferred to this. Only this one and this one too. This all of them we only have 7 in both, but we want 8. So we get from the last calcium, so it goes there, this goes there. So from all the calcium of all the calcium valence electrons are transferred to the phosphorus, which will make our stable thing. So we have Ca, which is 3, and they transfer the 2 electrons each, so it's 2 positive, and we have this table now. We have this of 2, and 3 negative. Because we get the 3 of the electrons from it. So that's how you can do the electron dot diagram thing. We are refreshing all the things, and this was the one of them. So after it, we will doing some properties of ionic compounds, but those are, like I told you, that we that the explanation of the that things. So now we are doing the some chemical formulas again, with when we do the molecular compounds. So molecular compounds thing we have to do now. So first one is the ozone. So ozone, all we know that what is ozone. Ozone is O3. Directly we have to know this. This is O3, and this is the gas. Next we have the dinitrogen tetrachloride. Nitrogen means and has the 2 of this. Tetrachloride means we have a 3. So this will make N2Cl3. So this is a solid one. So next we have NO. NO both have the only one, which is the mono. And the first one is the nitrogen. Second one is the oxide, but we have to make the mono oxide. We can't write the mono at the first of the thing. Don't write it over there. We write over there. So next one we have the N2Br6. N2 is a main nitrogen, but this is now dinitrogen. We have 2 of this molecule we have. So this is dinitrogen, and we have a 6. So 6 means hexa. So we have hexa. Bromine we have, so we have to drop, and we get ite. So it's dinitrogen hexabromide. So that's how you can see the chemical formula for molecular compounds, molecular substances. Next, most important thing, Lewis formula and the structural formula for the compounds. Here we have to make for the phosphorus ion. Very like a tricky of thing we have to do in this. So for this we have, what is the formula for phosphoride? So phosphoride is a polyatomic one. So we have PO4 3 negative of it. So P can be write it as like 1, 2, 3, 4, and 5. So we all know that oxygen has 1, 2, 3, 4, 5, and 6, like this type of electron dot structure when we make. Firstly, we have to figure out how to connect with this over there. So for this, we have 2 over there. If we put oxygen directly to this, they will make the 9, 10. They will make the 9. If we connected this part over there, so we get the 9 of the valence electrons, which is not stable dot orbital, which is against dot orbital. But if we transfer that electron to over there, like we made that electron, like we erase that electron from here, and for a convenience we put over there, and we put that oxygen over there. So 1, 2, 3, 4, 5, 6, 7, 8. So that means that that oxygen stable with that phosphorus, which is to the 8, and that's stable. Now this is going to stable now. Now we have to make another. For the another one, now the 3 of them, and 3 of them are directly like connected with each other. For this, now what can we do, that we put that electron back to this. So this electron go back to over there, and we exactly put that electron over there. So we connect with 1 dot. So when we count 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 6, 7, 1, 2, 3, 4, 5, 6, 7, we get the 7, 7 on all this. But we have that 3 negative now. This means we get more 3 of the electrons from here to get stable at the rotatable. So we put like 1. I made the cross sign to know that 3 negative of that. Now we get the all of the 8 electrons balance. But we have to make that big bracket over there, which is 3 negative. So this is one your Lewis one. For the structural one, we have to just convert dots into the signs, and we all have the single bonds, and this is 3 negative. So that's how you can make the Lewis and the structural formula for the phosphate ion. Sometimes you get the more complex one like this, not more than this. Next one we have from the stereochemical formula, means we have from the Vesper theory. So the Vesper theory is again very important topic as I when we're doing that. So we have to make the stereochemical formula for NO3 negative. So NO3 negative, NO3 negative we have to find. Now that how can we make this? So then now we have to again make that firstly the Lewis symbol. So Lewis structure we have to make like N we have, and has the five of valence. So I make like this. But for our convenience, because we have only now 3 of the oxygen, we connect the same as first oxygen like this. When we put like this, and that oxygen we connected like same as we connected in the previous one, because we have only one of the negative now, so we have to be careful when we put this. So we erase that electron over there, and we put the electron over there, and the same like this we have to put, same to this we have to put. But now that oxygen, like we have this type of oxygen, we have to convert this over there like this, not over there. So when we put this, we get this type of thing. From here we only left with the one of the things, so one negative we have, so we put one negative for our convenient. So when we put the bracket, and this is one negative now. So this is the Lewis structure, but we have to make the general formula for stereochemical formula. We have to make stereochemical formula. For stereochemical formula, we have only one satellite at one central atom, which is denoted by A. Satellite atom we have all the same of them, which is AS3. We have nothing non lone pair in this. But that thing I have to mention that over there, that lone pair is always have to know about if it is in central atom. If there's a central atom, we have to count only this, not these ones, because these ones are like the satellite atoms. So that's not a lone pair. We have two things, only the central atom if they have it. So this AS3, if you don't memorize this yet, so I told you that I will tell you some the easy method to how can we make that Vesper. We have to memorize that Vesper things, all the Vesper class and the stereochemical formulas. For this is the Vesper class of the triangular panel. And how can we make that thing? So we have N. So the triangle pyramid dwells. So this is O over there, this is over there, and this is double bond over there. Or should be bracket -1. That's how the CO formula we have to make from the Vesper theory. So the last question for this, so you have to find the bonding forces present in the samples of the following substances when we do the LDF, dipole-dipole, and the hydrogen bonding. So that's the question from to tell that what are the forces they have, all of these. So first is H2O. As I told you, the all should have the LDF. So this is LDF, this is LDF, this is also LDF. So H2, when we made the H2, so H2 is type of the band one. So this is a band, and we have assumption of the band that if they have the same of them, they have the same of the satellite atoms, this means this is the polar. So this means we have this as polar. So polar means this is the dipole. And if they have the hydrogen bond or not. So they connected with the H is connected with the O, which is from F and O. So this means they also have the hydrogen bonding. So if you see the water, so you can see that they have all the 4 forces. For the next one, we have NH3, this is LDF, and when we made the dipole of this, so N, so this is the triangular pyramidal type of thing. So when the triangular pyramidal we have, so this is again the assumption. So it's with the assumption, this means they have all the same satellite atoms. No, they have all the same satellite atoms. So this means this is the LDF, and we have a dipole too. And the N, the hydrogen is connected with the N. So this means this also have the hydrogen bonding. So at last we have LDF in this. This is C2H5OH. This is liquid. And when we made that hydrogen bonding this have, because this is connected with the O2, H connected with O, which is from FNO. When we made the diagram for this, which is a big diagram, and I will tell you that this is a dipole-dipole 2, because we will make when dipole-dipole force, we get some type of the triangle panel type of diagram when we made. So this means that this is the dipole-dipole 2, and as I told you, this is connected with the O, so this is the hydrogen bonding. So that's all you can find from there. So this is type of thing you have to know in this. Then they ask you about the bonding forces. So from there you can complete that unit, which is unit A, first unit of the gray line phases. We completed that unit, finally completed a unit, and now from the next lesson, and we started the another lesson for this chemistry, gray line chemistry. We started with the next lesson, which is such a short lesson, and we have more calculation in this, not the theory part more. So that's all for this lesson. Learning Message with EduVibe. Learn smarter but not harder. Please like, share, and subscribe to my channel. If you have any questions, let me in the comment section. See you in the next lesson. Till then, stay creative with EduVibe.